Hello, welcome to another lesson. In this lesson, we are building a network port scanner using Python. We are going to learn socket programming basics, connect ports programmatically, check if ports are open or closed, and create a complete multi-port scanner script. This is a real penetration testing tool, so let's dive in. Before we start, ensure that you have your Visual Studio Code with your Python scripts folder opened. So what are we building in this lesson? We are creating a port scanner that can scan single or multiple ports on a target system. It is going to check if each port is open, closed, or filtered, and after that, it displays results in real time and provides a summary at the end. This is similar to what Nmap does, but we are building it from scratch to understand the underlying mechanics. By the end of this lesson, you are going to understand how exactly network scanners work at the socket level. Now let's dive in. The first thing I did was to create a file named portscanner.py. Then after that, I wrote my code. This is the code to it. So I will test this first. I will save the code. Then I will come here and run Python, then portscanner.py. Now you can see that we have a banner here. The title of our tool is Simple Network Port Scanner Tool. And here you can see the options we are having. If you select option 1, it's going to scan single port. If you select option 2, it's going to scan multiple ports. If you select 3, it's going to scan common ports. And if you select 4, it's going to exit. So let's go through it. The first one we want to select is 1. So we are scanning single port. Now it's asking for target IP address. I can add 127.0.0.1. Then I hit enter. Now it's asking for the port number. Do not forget, we have 65,535 ports. So it's asking for the exact port between 1 and 65,535. So let's say I want to scan port 22, which is SSH. Now, if you look at the results here, you can see that port 22 SSH is closed. But before then, you can see something like scanning 127.0.0.1 on port 22, then scan started. It's showing you the steps sequentially. Then after that, this is the result, which is that the port is closed. We can try another thing. We can try to select option 2, and here we are going to enter the IP address again. Then you hit enter. Now it's asking that we enter multiple ports, and the ports will be separated with a comma. So I can add 22, 80, and 443. You can see the first one here, scanning 127.1. After that, we are displaying the scan started. Then after that, we have the number of ports that we scanned. Port 22 is closed, port 80 is open, and port 443 is closed as well. Then after that, we are displaying scan completed at this exact time. Then the total port scan is 3. The open ports we have is 1, and closed ports are 2. And here we are showing just the ports that are opened. So that's that for scanning of multiple ports. Let's now scan common ports. So for that, we can select 3. Then we're going to type in the target IP again. You hit enter, and it's going to scan through all the common ports. And if you look at our code here, all the common ports are defined here. So it starts from port 21 down to port 8080. And if you look here as well, you can see from port 21 down to port 8080 here. So after the scan is completed, you can see the total ports scanned. They are just 13. Open ports are 2, closed ports are 11. And these are the open ports here. The last option we can select is 4, and that is we are exiting our tool. And here you can see exiting scan responsibly. So this is how the port scanner works. Now that we know how it works, we can now proceed to write the code from scratch. So what will I do? I will highlight everything here, then I will delete it and I will save. Now I still have my port_scanner.py opened. If you don't have this file yet, you can just type touch, then port_scanner.py, then you run it and it's going to create the file for you. And once it has created the file for you, we want to start writing our code. The first part of our code is where we are going to be importing the 3 modules that we need. And this is the section. You can see that here. We are importing socket, we are importing sys, and we are importing datetime too. So socket is the core module for network programming in Python. It lets us create network connections at a low level. And sys gives us system-specific parameters and functions. We use it to exit the program cleanly. And the datetime, which is the last one, helps us timestamp our scans. And that's the essence of importing these three modules. The next thing we want to do is to define our constants, and that is for our common ports. So this is what that looks like. And here we are creating a dictionary, and the dictionary maps port numbers to service names. And this means when we find port 80 opens, we can tell the user that it is HTTP instead of just showing a number. And this makes our scanner more useful and professional. Using dictionary here is smart because it gives us a time complexity of O into bracket 1. If you're familiar with time complexity, you are going to know this. So it will look like this, O into bracket 1. So this is the time complexity. So the reason why we are using dictionary is because it gives us O into 1 lookup time. That is, we can instantly check if a port is in our common port list and get its service name at the same time. So that is for the time complexity. If you want to learn more about time complexity, you can read more on that. Now that we have defined our constants, the next thing we want to do is to create our core function, and we are going to be naming the function scan port. And here is the code for the function. It starts from here down to here. I'll provide the source code in the description in case you want to practice. The link to the file that contains the code is added in the description. Just click on it and you're going to see the code. And the function we are creating here is where the magic happens. So let me break it down to you step by step. First, we are creating a socket object, and that is where you are seeing socket.socket. And that takes two arguments, which is af underscore inet, which means we are using IPv4 addresses. Also, we have socket underscore stream, which means we are using the TCP protocol, not UDP. And why are we using TCP? Because TCP establishes a full connection. When we try to connect to an open port, we get a successful connection with the help of TCP. And when we try a closed port, the connection fails, and this is called a TCP connect scan. Then after that, we set a timeout, and this is crucial. Without a timeout, if a port doesn't respond, our scanner hangs forever. With 1 second timeout, if the port doesn't respond, within 1 second, we move on, and this makes our scanning fast. And after that, we use connect underscore x, not connect. And why did we use connect underscore x? Because connect raises an exception if the connection fails, but connect underscore x returns an error code instead. If the result is 0, the connection succeeded and the port is open. Any other number means the connection failed and the port is closed, and that is why we are using connect underscore x. After that, we are getting the service name from our common underscore port dictionary using the get method. If the port is not in our dictionary, we default to unknown. Finally, we close the socket because it is good to close sockets when done to free up system resources. And at the end of everything, we are returning three values, which are the port number, the status, that is open or closed, and the service name. This gives the calling code everything it needs to display results. And the try except blocks you're seeing here handle errors. So if there's a host problem, we catch the guy error here, and if it is a general connection problem, then we catch the socket.error here. And this makes our scanner very robust. Now let's look at the function that scans a single port and display results. So we are going to name the function scan underscore single ports, and we're going to be passing two parameters inside, which are target and port. So let's do that. Now this is the function here. So this function is a wrapper around the scan underscore port function, and it adds user interface elements. First, what we are doing here is that we are printing a message showing what we are scanning, and the f string there embeds the target and port directly into the message. After that, we print a timestamp using date.now method and format it with the strf time, and this shows exactly when the scan started, which is important for logging and documentation. After that, we call the scan underscore port and unpack its three return values into port underscore num, status, and service. Based on the status, we print different messages with different symbols. The scale bracket plus for our open ports, the scale bracket minus for closed ports, and the scale bracket exclamation for errors. And why are we using different symbols? Because it makes output easy to scan visually. You can quickly spot open ports because they have the plus symbol. You can quickly spot the open ports because they have the plus symbol, or quickly spot errors because they're having the exclamation symbol, or spot the closed ports because they're having the minus symbol. After we are done with this, we are now going to create the function that scans for multiple ports. And we are going to name the function scan multiple underscore ports. Also, we are going to be passing two parameters, which are target and ports. Let me walk you through this function. At first, we are creating two empty strings, and the first one is the open underscore ports, and the second one is the closed underscore ports. And these are created to track our results. After that, we are creating a loop here, and what this does is that it loops through each port in the ports list. For each one, we call the scan underscore ports function. You can see that here, and then we get the results. So if the port is open, we print it immediately and append it to open ports that we created here. And we are storing both the port number and the service name as a tuple. So if the port is closed, we print it and we append just the port number to closed ports. And why are we tracking these separately? Because at the end, we want to show a summary. And if you look at the first demo I did before the code walkthrough, you can see that there. The summary is really useful when scanning many ports. So instead of scrolling through hundreds of lines, you get a clear count and the list of open ports at the end. After the loop completes, we are printing a separator line, the completion timestamp, and statistics. We are showing how many total ports were scanned, how many were open, and how many were closed. And finally, if any ports were open, we list them in a clean format. We loop through open underscore ports and print each one with its service name. And this is very good because it gives the user a quick reference to attack surface. And if you look at the demo I did earlier, you could see that after all the information, we were able to see just the open ports at the end of everything. So that's all for the function responsible for scanning multiple ports. Now let's look at the function that scans common ports. So we can name that scan underscore ports, and we're going to be passing just a single parameter there, which is target. And this is what that will look like. This is it here. And I must confess that this is beautifully simple because we've designed our code well. So this function just gets all the keys from our common ports dictionary that we created at the top here. You can see that here. And you can see that it contains port numbers and their respective services. So what we are doing with the common underscore ports is that we are getting all the keys from the common ports dictionary we created. And if you look at it very well, you see that the keys are the port numbers. So we are converting the keys because these are keys and these are the values in dictionaries. And as we are now getting the keys, we are now converting them into a list. And then we are now passing them to the scan underscore multiple ports function. You can see that here. So this demonstrates good programming practice, which is don't repeat yourself. We already have a function that scans multiple ports, so we just call it with the specific list we need. The list function converts dictionary keys to a list, and dictionary keys are special type in Python, so we need to convert them to use in our scan function. The next thing we want to do is to look at the input validation, and we're going to create a function for that as well. So we will name the function validate underscore IP, and we are going to be passing a single parameter to it, which is just the IP. And if you look at the function here, what it does is that it checks if a string is a valid IP address. We are using the socket.inet.18 here, which stands for Internet Address to Network. This converts a string IP address to its binary representation. Now, if the IP is valid, this succeeds and will return true. But if the IP is invalid, like 999.999.999.999, or maybe hello, it then raises a socket.error exception. We catch that exception and we return false. Now, why are we validating? We are validating because if we don't, the scanner can crash with confusing error messages when someone enters an invalid IP. So with validation, we can give a clear error message and ask them to try again. This is defensive programming. So my recommendation for you is always validate user input before using it. Let's now look at the main function that ties everything together. And we'll be naming that function main, and this is it here. You can see it starts from here down to here. So this main function now starts with the title banner, as you can see here, Then it enters a while through loop which runs forever until user chooses to exit. When we tried the demo earlier, you saw that as we're choosing the options and we're done with one task, it is still returning all the options back to us so that we can select another option and try another task until we chose the fourth one, which is number 4, and that is responsible for exit. So it is this main function that handles all of that. And if you look inside this loop, we are displaying a menu and we're getting the user's choice. So for option 1, we are asking them the target IP, and after that, we immediately validate it using our validate IP function. So if it is invalid, we print an error and continue, which skips to the next iteration of the loop, and then it shows the menu again. And after that, we are asking for the port number, and this is wrapped in a try except block because the int method raises a value error if the user types something that is not a number. After converting to an integer, we then check if the port is in the valid range. Port numbers go from 1 to 65,535 as I mentioned when I was doing the demo, and that is the maximum because ports are 16-bit numbers, and 2 to the power of 16 is 65,536. So if you are starting from 0, you are going to count 0 till 65,535. So after all validation passes, we then call the single underscore scan underscore port method. You can see that here. The extensive validation we are doing makes the tool user-friendly and robust because it catches mistakes early and gives helpful error messages. Now let's go to option 2, which is responsible for scanning multiple ports. So this is what that looks here. You can see it from here down to here. So this option 2 lets users scan multiple ports as we've seen earlier. And again, we are validating the IP address first. After that, we now ask for ports as a comma separated list. We split the inputs by commas, strip white spaces from each piece, and convert each to an integer. This is a list comprehension, which is concise and Pythonic. After that, we use the all function to check if the ports are in the valid range. The function returns true only if every item in the sequence is true. If even one port is out of range, all returns false. And this handles cases like 22, 80, maybe 999,000, where most ports are invalid. And if you look at that case, most ports are valid, but one is not, which is the 999,000. So in that case, we catch it and then we give a clear error. Now that we are done with option 2, let's consider the option 3 and 4. And for that, we'll be using our elif statement and we're going to end it with the else statement. So this is what that looks like. You can see this is for option 3, then down to option 4 here. And at the end of everything, we ended it with an else statement. So if you look at option 3 here, it is very straightforward. What it's doing is that it's validating the IP, then it calls the scan underscore com underscore ports function, and that is simple and clean. For option 4, we are using this to exit the program. So we are printing a goodbye message here, and then we are calling the sys.exit function, and the 0 here indicates successful termination. In Unix or Linux, exit code 0 means success. Any other number indicates an error. And if you look at the goodbye message we are printing here, it is exiting port scanner, scan responsibly. You saw that when we were doing our demo. And lastly, we are having our else block here, and this handles invalid inputs. So if someone types 5 or types a string such as hello, we tell them the option is invalid and then show them the menu again. This menu structure is standard for command line tools, and I love it because it is intuitive and handles errors gracefully. Finally, we are proceeding to the script entry points, and here we are going to be adding our if name equals main block, and you can see that here. If you've seen some of the previous lessons, then you will not be new to if name equals main. But if you are new to it, what it does is that it runs the main function when the script is executed directly. But this time around, notice that it is wrapped in a try except block. You can see that here. We are doing that because we are catching the keyboard interrupt, which is raised when someone presses Ctrl C. And why are we doing that? We are doing that because during a long scan, users might want to cancel. So without the exception handler, Pressing Ctrl C shows an ugly Python traceback, and with it, we print a clean message and exit gracefully. This is professional software engineering. So you must always think about the user experience, even in edge cases like cancellation. Now that we are done with this, we can save the file again and rerun port_scanner_py code. Then you hit enter and you can see that everything still runs fine. So if I want to pick option 1, you can see enter target IP address. Then I can enter 192.168.1.1. Now you can see that it's telling me that the port is closed. So if I want to scan multiple ports, I can select option 2. Then I add the same IP address 192.168.1.1. Then I run it, and after that I can type port 21, 23, 80, 443, 8080. Then I run it, and after that you can see that it is running my scan. For port 21, that is closed. Port 23, which is meant for telnet, that is closed as well. Port 82 is closed. Port 4432 is closed. Port 8082 is closed. So all the ports I checked for are closed for this particular IP address. You know, when we first tried it, we used 127.0.0.1, but for this IP address, everything is closed. And if you come down, you can see more information about it. You can see when the scan was completed. You can see the total number of ports that were scanned, the total number of ports that were opened, none is open, and the total number of ports that are closed, which are 5, which means all our ports are closed. And again, you can see that it's returning the options back for us. So we can select option 3 again, and after that I can type the same IP address 192.168.1.1. Then I run it. So it's scanning all the common ports for that IP address. And if you scroll up, you can see that all the ports are closed for the IP address. If you look here, you can see that this is only accepting integers, that is option 1 to 4. So if I am typing a string, for instance, I'm typing hello, or I'm typing something else outside this, and I run this, you can see that it is handling our error gracefully. It's saying that invalid option, please select 1 to 4. So it is handling the errors perfectly. Even after I've selected the first option, and here I'm typing, let's say 999.999.999.999, which is an invalid IP address, and I run it, you can see that it's saying invalid IP address. So the errors are being handled perfectly. Let me explain the underlying mechanics behind the socket scanning. As I said earlier, we use the connect_ex or connect_x. So when we call connect_x on a socket, here is what happened at the network level. The first thing is that our computer sends a TCP SYN packet to the target port, and this is the first step of the TCP three-way handshake. So if the port is open, the target sends back a SYN ACK packet acknowledging the connection. Our socket then receives this, and then the connect_x would return 0 for success. But if the port is closed, the target sends back an RST packet, which means reset, no service here. That is what RST packet means. Then after that, our socket receives this, and then connect_x returns an error code. Also, if the port is filtered by a firewall, we might get no response at all. And that is why we set a timeout. That is, after 1 second of silence, we assume the port is filtered or probably the host is down. And this process is the TCP connect scan, as I mentioned earlier. The same technique is what Nmap uses with the -st flag. It is reliable but not stealthy because it completes the full TCP handshake, which gets locked by the target system. More advanced scanners use techniques like SYN scans, which don't complete the handshake, or they use UDP scans for different protocols. But TCP connect scans are perfect for learning because they are simple and they work without requiring root privileges. Now, for this scanner that we've built, what are the improvements you can make? This scanner works well, but you could extend it in many ways. You could add threading to scan multiple ports simultaneously, making it much faster. You could implement banner grabbing to identify service versions. You could add UDP scanning support for services like DNS. You could save results in a file for later analysis. You could integrate with a vulnerability database to automatically flag known vulnerable services. You could add color coding, just like we did in our last lesson, to outputs using libraries like Colorama. You can do different things, but we've built the foundation in this lesson, and the foundation is solid. So all these enhancements can be built on the core concepts that you already have. So before we go, here is a challenge question. And the question is, what does socket.sock underscore stream mean? And why do we use it for port scanning? I repeat, what does socket.sock underscore stream mean? And why do we use it for port scanning? Thank you for seeing the video till the end. I'll be expecting to see the answer to the challenge question in the comment section. Also, do not forget to like, share, comment, and subscribe to our YouTube channel. Thank you so much and see you in the next lesson.